projector today. Give that a shot. Okay. And we will go from the current slide. All right. And this is Brianna, right? Okay. Now, first, just a few announcements. If you're interested in the math team, they're meeting Friday 11 to 1. Change the time a little bit. And rather than doing math team stuff, they're reviewing for the end of the term. So actually, if you want to go participate with the math team, you get to ask the coach, Ms. Gerasi, any question you want to about anything they're reviewing for the end of the term, final exams and stuff. Then Monday, back at 3 o'clock, they'll be doing math team stuff again, and you can participate in that, which you'll find very helpful too, I think. Tutoring, if you want to know more about this, I've described it before. We got student support services up here on this level, just down the hall about 2/3 away. If you go down the stairwell there, the Space Center is down there. You can either get tutoring, or if you've made an A or a B in a course before and they need tutors in that, you can actually tutor. So good opportunity there. And I hope you know what's happening tomorrow. Tomorrow is Honors and Awards Day. It actually starts at 10 o'clock in the morning over on the Birmingham West Campus, the Arthur Shores Fine Arts Building, which is also the gymnasium, Fine Arts Gymnasium, I guess that makes sense. Okay, and if you're participating, I know they want you there much before, at 9, okay? We need to be there by 9:30, but so the students need to be there by 9. And so morning classes are canceled after 9 o'clock. So if you got an 8 o'clock class, check with your instructor and stuff, but you probably only go 8 to 9. I'm going to teach till 9 and then let them go early because it normally goes to 9:15. But then the 9:30 classes wiped out altogether. Okay, check with your instructor first. Make sure they're not going to show up and you won't. If you are participating, you've got to be there. If you're not participating and you have an adjunct instructor who's trying to catch up or something like that, then you might have class, but generally not. Classes are technically canceled at 9, and that makes them 9:30 classes. I don't know about the 11 o'clock classes. I don't think those things have ever gotten over with in less than 2 hours, much less than 2 hours. They've never gotten over with in an hour. So I have a feeling 11 o'clock classes may be canceled too, but check with your instructor. Don't assume, okay? But I know they'll be done by 12, so the 12:30 classes will be meeting. Okay, so there's that. Then the one other thing was pointed out to me. I just pulled it says it's a test, but it was the test I gave last time, off the my resource page, thinking it was a Chapter 13 test. Turns out the second page is Chapter 14 stuff. So you only need to answer, is it 1 through 11? Okay. The rest of those on factoring, if you want to try them, you can do them. Now, this part is only, the bonus part is only going to be good for this week, okay? If you wait and turn it in later, there's no bonus points. But if you want to do any of those additional problems, if you get them right, you get bonus points. If you miss them, it doesn't hurt you at all, okay? So you're free to try some of those if you would like, and so that could give you a few extra points. But this offer ends 1 week from today. Any tests that come in, or those quizzes that come in after next Wednesday, there's no bonus, okay? This is only good for those, if you turn them in today, Monday, or next Wednesday, okay? The bonus only holds for that time. I don't want people hanging on to them and turning them in the last week of class after we covered all this and wanting bonus points, you know. Got to get them in within a week, and the clock starts today. All right, any questions? Okay, we're continuing in exponents and polynomials, chapter 13. Today we're doing 13.6, dividing a polynomial by a monomial. One objective, divide a polynomial by a monomial. Pretty straightforward, huh? And here's the rule, okay? To divide a polynomial by a monomial, divide each term of the polynomial by the monomial. Because if you have a plus b divided by c, that's a binomial divided by a monomial, then split that into a over c plus b over c. It's just the reverse of when you get common denominators, add the numerator, keep the denominator. You're now breaking it apart the other way, so that's what you do. Now this, of course, won't work if c is equal to 0, but it never would have worked. So here's an example. And this is so simple, it makes no sense almost. 2 plus 3 over 7, you look at that and you know the answer, right? What is it? 2 plus 3 over 7. 5/7, okay? But you could do it as 2/7 plus 3/7, and those add to be 5/7. Now, I find it easier to do this way than that way. But this one makes a little more sense. N plus 5p over 4y. There's no numbers there, that are not many, that you can add or do anything with. So that's just n over 4y plus 5p over 4y. Now, if any of these had any common things, then you can divide those out. Okay? So that's the rule we'll be following by dividing polynomials by monomial. So let's do the first one here. Okay? Now this is the first one in on the slide set, slightly different from example 1 in the book, but pretty close. Okay? Now, I'll write it the same way they did. Okay? Just, okay, 6 y to the 5th minus 10 y cubed divided by 2y squared. Okay? What would be your first step? Okay? Split them up. 6y to the 5th over 2y squared minus 10 y cubed over 2y squared. Now, is there anything we can do to simplify this one? You actually can, and I usually do, but the way that the book is teaching it, I'm just going by that. If you see it and understand it the other way, go for it. Okay, perfectly fine. But what would this be? What could you do here? Yeah. 6 divided by 2 is 3. Okay. And y to the 5th divided by y squared is y cubed. There's your first term. Minus 5. Why not? Okay. All right. See how it works? Okay. What you're doing is kind of reverse of subtracting. Okay. If you have two fractional forms that you're subtracting, you've gotten the common denominators, then keep the denominators, subtract the numerators. Okay? Now, there's nothing you can really subtract there because those aren't like terms. So what they're saying is go the other way and put them each over the denominator, just like you would have had with fractions to begin with, and then simplify each term, term by term. Now, I don't know if this was your question, Daniel, or not, but if you leave them over this, if you understand, just divide this into both of them, it's perfectly fine. Just do it. But some people might divide into this thinking they already used that up and not have anything to do there. This way it shows you, yeah, you can do them both with that. So I think it's a fail-safe. Just trying to make sure people see they get all out of it. Okay? Any questions on that? Does that make sense, what I'm doing? Okay. Let's erase this, and let's see how they did it. I'm guessing it's about the same, but let's just see. Okay, they first wrote it that way, just like I did. Then they split that up, just like we did. And then they simplified, just like we did. Everybody see how they did it? They didn't show the steps there, but they did the very things. All right, that was example 1. If you wanted to check and see if your answer makes sense, as in any division problem, if you're dividing the dividend by the divisor, getting a quotient, you can multiply the quotient by the divisor and you should get the dividend. And they do show that in the text. They didn't talk about it earlier, but they do show that. So you can check your answers that way. Let's see if they've got example 2. Oh, here's they're going to show the checking. Multiply the divisor by the quotient. And what do you get? 2y squared times 3y cubed. 2 times 3 is 6. Y squared times y cubed is y fifth. Minus 2 times 5 is 10. And y squared times y is y cubed. Yeah, you get exactly that answer. Division undoes multiplication, multiplication undoes division. Okay? And that gives you exactly the same answer. Okay, because division by 0 is undefined, the quotient is undefined if y is equal to 0. From now on, we'll assume no denominators are 0, so we don't have to say that every time. Okay? Yeah, I bet you they'll still say it every now and then. So let's do example 2. You tell me what you would do. You want me to write it out first? 20n to the 5th plus 8n to the 4th minus 5n squared divided by 4n cubed. What would you do first? Split it up. Okay. 20n to the 5th divided by 4n cubed plus 8n to the 4th divided by 4n cubed minus 5n squared divided by 4n cubed. Okay? What can you do to that first one? 5. 20 divided by 4 is 5. And n to the 5th divided by n cubed, if you divide it like that, or just subtract the exponents, however you want to do it, that gives you n squared. Next, plus 2n minus 5 over 4 leave the n there. N squared in the numerator is n times n cubed in the denominator is n times n. The 2 of the n's go out, and you're left with a 4 over n here. Now, they didn't specify whether they wanted you to write the answers with negative exponents or not. This, to me, is a perfectly good answer. If they didn't want variables in the denominator, you could have written this, and this is also perfectly correct, 5n squared plus 2n minus 5/4 n to the minus 1. Right? That's also a perfectly good answer. Let's see which one they chose. Or maybe something else. I think it's going to be one of those. Okay, they first wrote the divisor over the dividend over the divisor. Then they split it up, just like we did. Then, they wrote it with the n downstairs. Does that make sense? Got it? All right, good deal. And, okay, I guess they're going. Okay, the quotient is not a polynomial. Okay? That part of the quotient is not. I guess that's okay with them. If you wanted to check it, you can multiply that through. And this gives you 20n to the 5th. Good. This this gives you the 4's divide out, and n will go into n cubed, n squared times, so 5n squared. Sure enough, that works too. Oh, and they show how to do that, and sure enough, that's what you get. You get the dividend at the end. Make sense? So if you got time on a test, check your answers. I'd much rather grade a correct answer than an incorrect answer. So check them, make sure they work. And that way it makes my job easier. And I'm lazy. I want it to be as easy as possible. So get them right. Here, I get really upset when you miss them, and I have to do more work. Okay? All right. Example 3. All right. These are very similar to one in the book, but they're not just like them. Here's a negative 15 m to the 4th plus 10 m cubed plus 5 m squared divided by 5 m squared. What would be the first thing you'd want to do to this one? Split it up, and that would give you what? Negative 15 m to the 4th over 5m squared plus 10m cubed over 5m squared plus 5m squared over 5m squared. Okay, what does that first term become? Negative 3 m squared plus 2m plus 1. 5 divided by 5 is 1. M squared divided by m squared is 1. 1 times 1 is 1. Perfect. A little bit of a tendency of mine to want to factor that, but since we haven't done factoring, we're not going to. So we'll just leave it alone like that. Now, of course, you could check this by multiplying by the divisor. That would be minus 15m to the 4th. Perfect. Plus 10m cubed. Perfect. And plus 5m squared. Right. Okay. So we can check it just looking at it there. You don't have to write it out unless it's helpful for you to. Then by all means do it. So let me erase this unless there's questions. Any questions? Okay. So they wrote it as a rational expression. Okay. Then they split it up just like y'all did. Then they operated on each term just like Patricia did. Patricia came in. Okay. We're on example 3. Not the same example, but similar to the example on page 893, section 13.6. Okay, there's the answer they got, which I think is exactly the answer we got. And they checked it by multiplying the divisor times the quotient and doing that, distributing the 5m squared with each term that's in the quotient. You get minus 15m 4th plus 10m cubed plus 5m squared, which is our divisor. So, dividend. Made the check work. Any questions on that? Okay. How about example 4? Wow. Okay. Now, the one in the book, pretty interesting one. This one's a lot less complicated. Well, it has its own complications, but the numbers are smaller anyway. So this would be 9g 8th h cubed plus 12g 5th h 9th minus 6g 6th h 5th plus 2g cubed h 4th divided by Courtney, right? Okay. All right. Anyone else come in since I called it off? Okay. Divided by a negative 3g squared h cubed. What would be your first step? Split them up. Okay, so that would read how? 9g8 h cubed over a negative 3g squared h cubed plus 12g fifth h ninth divided by a negative 3g squared h cubed minus a 6 g6 h fifth over a minus 3 g squared h2 h3, sorry, and running out of room. Plus 2 is going to be down here, g cubed h4 divided by a negative 3 g squared h cubed. Okay, let's deal with the first term. What do you notice there? Negative 3. 9 divided by negative 3 will be negative 3. G to the 6th. Done. Because h cubed divided by h cubed is 1. Next. Really? Minus. Okay, plus divided by minus is going to be minus. Say again. 4. G what? Cubed. H to the 6, isn't it? 9 over 3. 9 divided by 3. Is that right? Is that what you said?
Yeah.
Oh, okay. I can't hear well. Okay. Next. Plus. 2. G to the what? 4th. Good. H squared. Next. Minus 2/3. You can't divide anything there, so that's perfectly okay. G on top. H on top. That's it. Now, there's a couple ways you could write that one. The first part stays the same. Minus 3g6 minus 4g cubed h6 plus 2g, is that a 4? Yeah, g4 h squared. And you could write this as minus 2gh over 3. Either one of those is fine. How you write that last term. Okay. So, let's see. Any questions on that before we go to them? Okay. Dividing a polynomial by a monomial is pretty easy. Okay. It can get hairy if you notice the one in the book. For example, for 180 x to the 4th y to the 10 minus 150 x cubed y8. I mean, it's just bigger numbers, but the principle is the same. Exactly the same. Okay? Now, the other difference in the one in the book, they left you with x, y's in the denominator, but we've had those before too. Okay. All right, to erase? Okay. Then let's see how they did it. They wrote it out first, taking most of the length of the page, width of the page. Then they split it up with 9gh, g to the 8 h cubed divided by your denominator minus 3g squared h cubed plus 12g fifth h ninth divided by negative 3 h2 g2 h3. I need your right. Anyone else come in since I called roll? Okay. This is example, well, it's like example 4, bottom of page 893. It's the one in the slide set, which is a little different from the one in the book, but same principle. And the third term was minus 6 g6 h fifth over minus 3 g squared h cubed. And the last term being plus 2g cubed h4 divided by a negative 3g squared h3. Okay? And in this one you see your number part will be a minus 3 g to the 6 with no h's, because 3 minus 3 is 0, so, okay, fine. They are showing off the plus signs, okay? And then those are minuses, and those are pluses. Isn't that nice? I guess what they're saying is be sure, pay attention to your signs. They will sneak up and bite you where you don't want to be bitten, okay? So, so here we have minus 3g to the 6, yes. Minus 4, plus divided by minus is minus. Minus 4, g cubed, h6, perfect. And now it's a plus. Minus divided by minus is plus 2, g fourth, h2. And finally, a plus divided by minus is minus 2 over 3. Now, they wrote it the way, keeping all the letters in the numerator. You could have written the negative 2/3 as a fraction followed by the letters, which were numerator-type places, but either way you write it is fine. Negative 2gh over 3. Makes sense? Okay. All right to erase? No? Okay. Got it? Everybody? Okay. Whoa! That was the last of... Yep, it is. Okay. Let me remind you, the examples in the book are not the ones we did in class, so those can be done. Good thing to do because they're all done step by step for you. Then the ones in the margins, in the gray margins, those can be done. They don't show you step by step, but they do show the answers. Okay? And then the homework exercises, let's do number 1 together. This is on page 894. In the statement, do I need to write this down? Probably. Not all of you have books, do you? Okay, what I'm going to do is back off here. Okay, I write it down here. In the statement, 6x squared plus 8 over 2 is equal to, this makes it a statement, a complete sentence, 3x squared minus 4. Okay? Blank is the dividend. What's your dividend? Which of those entities is your dividend? No, that's the visor. 6x squared plus 8 is your dividend. Blank is the divisor. 2, y'all remember well, and blank is the quotient. (3x squared minus 4). That's the quotient. Okay? Dividend, divisor, quotient. Now, writing it this way leads to what it looked like Daniel was wanting to do. You take the 6x squared, divide by 2, and that gives you 3x squared. You get the plus. Oh, did they make a mistake or did I? Oh, I didn't copy it right. That's a plus 4. Okay. My eyes aren't good. Okay. And then you can do this. 8 divided by 2 is 4. After a while of writing them out, splitting them up and stuff, if you get lazy enough, you can do this. You can just go straight to here. But don't do it before you're confident you're doing it right. Okay? All right, so that was 1. Number 2, the expression 3x plus 12 over x is undefined if x is equal to what? 0. You can never divide by 0. Very good. Number 3, to check the division shown in exercise 1, which is one I have written there as a 6x squared, blah, 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 multiply blank by blank and show that the product is blank. So what do we multiply? Multiply the 2 times the 3x plus 4, x squared plus 4, see that you get that. Perfect. Okay? Is the expression, all right, here's a question. Is the expression 5x squared minus 3x plus 6 plus 2 over x, is that a polynomial? Say again? No, why not? What's that? If that was a 2/3, that would be a polynomial. But 2 over x is not a polynomial. Why? For a polynomial, your x's have to live in the numerators with whole number powers. They can't have fractional powers, they can't have negative powers. Whole number, positive whole number powers. This is not a polynomial term. These are polynomial terms. Those are polynomial terms. Those are polynomial terms. Those are polynomial terms. If you have an x in the denominator, not a polynomial. Okay? All right. Okay. I'll let you read through the rest of those. The ones I would definitely work on would be any of the problems 9 through 20, goodness gracious, 9 through 32, okay? 25 and 26 are a little different from the others, but same basic stuff, okay? And then try 33 and 34, and take a look at 35 and 36, okay? That's it. That's it for 13.6. Okay? Oh, and for those who came in late, is anyone here that did not get the quiz last time? Okay? Some of you did not, so let me find that, because what I'm going to say next won't make any sense to you unless you have the quiz. Now, of course, this doesn't call it a quiz. It says Unit 3, MTH098. It doesn't say quiz or anything else besides that. Okay. Anyone else over here? Okay. That feels like it's too thick. Probably too thick. No, that's Unit 2. Did I give you Unit 2 or Unit 3? Unit 3. Okay. Somehow they got mixed up. I was going to say, how did that one get mixed up in there? I don't know. I'm beginning to be doubtful. Is the first one on yours, identify the polynomial as a monomial, binomial, blah, blah, blah? Okay. All right. I don't know how yours got mixed up in the other. Check and see. Look on the back side of the page. Yeah, okay. Okay. I didn't want to give you a big. Okay. Thank you. Anyone else need that quiz? All right. Now that you've got the quiz, I didn't realize this until I think Ariana was the one pointing it out to me. Right? Okay, yeah. They're factoring here. Factoring is the next chapter. So evidently what they did, they combined their Unit 3 and Unit 4 together. Okay? So your test, your quiz, is 1 through 11. Okay? Now, if you want to try factoring, you can try the others. If you get them right, you get bonus points. If you get them wrong, it doesn't cost you a thing. Okay? If you don't want to try them at all, it doesn't cost you a thing. So it's just a way to get a few extra points. So do 1 through 11. Those will be graded. The others, you'll get credit only if you get them right. Okay? Completely right, by the way. And to get the bonus points, you must turn this in by next Wednesday. Okay, I usually give you more time than that to do a quiz, but to get the bonus points, you have to turn it in by next Wednesday. Okay? All right. Any questions? All right. Now, And as soon as we get those in, especially from you folks, we'll have the test on chapter 13. So let's now move. And by the way, let me tell you this. On that, the quiz, all multiple choice, weren't they? Those first 11? Your test will not be. Your test will be write out the answer. I don't particularly care for multiple choice, not because of, but for the same reason that the term is used. Some people call it multiple guess. You know, oh, I don't know how to do this, but that one looks right. You know, you might actually get it without knowing how to do the problem, okay? So I want to see your work. I want you to actually work the things rather than guesswork. Okay. Okay. All right. Okay. Let's move on to 13.7. Okay, chapter 13 is still exponents and polynomials. All right, let me get the slideshow set up. And this, again, is a pretty short section. Wait a minute. That's what we just did. Sorry. Okay. I must have hit the wrong one. Oh, okay. I thought I hit 13.7, but evidently my finger moved up. This is taking a lot longer to load. It must be a bigger section. All right, chapter 13, still exponents and polynomials. We'll set up from the current slide. And 13.7 is dividing a polynomial by another polynomial when they're focusing on the poly part. A monomial is a polynomial, it just has one term. They're talking about polynomials with more than one term. And so our objectives here are obviously to divide a polynomial by a polynomial, but then we're also going to apply division to a geometry problem. That sounds fun. So let's hit it. Okay. I was going to do this, and they beat me to it, okay? Okay. Let's start with dividing whole numbers. If you were told to divide, let me get my pen set up. If you were told or asked to divide 6696 by 27, okay, that would mean, and we're going to do long division, outside the house you'd put the 27, and inside the house you put the 6696, right? How do you do long division? Time out first, before you answer that. In addition, you usually start and go right to left. Right? In subtraction, you start and go right to left. In multiplication, you start and go right to left, but in division, you go left to right. Okay? Strange but true. So where would you begin here? Well, you could even start with 27 into 6. That won't go. So you use the first six terms. 27 into 66 will be how many times? Twice. And then what do you do? So the first step is to divide. Second step is to multiply. And what does that give you? 54. Excellent. And then what do you do? Subtract. And what does that give you? 12. Now, time out. Okay? If this 12, the remainder, sub-remainder here, came out greater than 27, stop, go back and put it one more time, or more than one more time, because you didn't divide enough. Because this always has to be less than that before you proceed. Okay? So you've got the 12, that's less than 27. What do we do next? Second, bring down the 9. Is that what I heard? Okay. Then you do what? Divide again. 12 will go into 129. About how many times? Second, 8, you think? Is that what I heard? Let's try 8. See what happens. 8 times 7. Don't pull out the calculator. 8 times 7 is 56. Carry a 5. 8 times 2 is, whoa, nowhere close. Okay? So that didn't work. If your product came out greater than what you had, then you did too much. Okay? I won't often tell you you've done too much. Okay? Now, here's what I was going to say before someone said that. To make a guess at this, let's take the far left into the far left. Because 27 is actually closer to 30 than it is to 20. Let's round this up and make it a 3. 3 will go into 12 how many times? 4 times. That's going to be my first guess. Not 8, but 4. Okay, and what do you get here? 8 times 7 is? Wait, who did that? Who wrote that down there? Okay. What's wrong with you people? Okay. Okay. 4. Okay. 4 times 7 is 28. Carry a 2. 4 times 2 is 8 plus 2 is 10. Subtract, and what do you get? Oh, I should have asked you. What do you do next? Subtract. What do you get? 21. Is that more or less than your divisor? Less, so you're okay. If I had done 3 on the previous one, it would come out more, and yeah. Okay, and then what do we do? Bring down the 6. And then we go again. You say 8. This time it will work. Okay? Perfectly. That gives you 56. 16 and 5 is 21. All right. Now that means 2 things. At least 2 things. This divides into that exactly. Okay? That's one thing it means. The second thing is that this now is a factor of this, as is this. These are factors because the remainder is 0. Now we're not doing that so much now, but just to know that. That means that if this goes in a remainder of 0, that means these are factors of this number, okay? Which we aren't really dealing with yet, but it's going to be something we do, okay? So, this was a refresher, because I know most of you, for most of your lives, have used calculators, especially when you have big numbers to divide like this, which is fine. But in order to divide polynomials, you have to remind yourself, how did you divide long division? Because that's what we use when we're doing this. So, let's move on, and now they're doing the same thing, and you'll see they did the same thing. 27 into 66, 2. So you divide first, then multiply, then subtract. Divide next, multiply, and then subtract. Divide next, I'll bring down. I should have say bring down. Divide next, 8 goes remainder of 0. This means, and you multiply the check, 27 times 248. If you do that on your calculator, or you can do it however you want to, it does come out exactly this. Hard to read that, but if you're red-green colorblind, you're particularly hard to read that. Okay. I have a nephew who is. So not much fun with that. Okay. Now, if you had a remainder, then what you do is multiply this times this, and then add the remainder in. With the remainder 0, you don't have to add 0. Okay. Good refresher on how to divide whole numbers? Okay. Now we're going to move to dividing polynomials. Okay? And again, divide the big polynomial, the divisor, by the little polynomial, the big polynomial, the dividend, by the little polynomial, the divisor. And again, set up the house. The little one goes into the big one. The divisor, the by, goes into the big thing. Okay? All right. Now, how do you think we're going to begin? Should we start at the right? Yeah, start at the left. And start the leftmost part of the left. So we'll do 3x into 6x cubed. Or you can split that up and do numericals first and variables second. So 3 will go into 6 how many times? Now I may write mine in different places from them, but it's okay. 3 will go into 6 2 times. X will go into x cubed. Say again. X will go into x cubed. X squared times. Perfect. You see that? Yeah. Okay. All right. Think of it written over each other. Subtract the exponents. Whatever you want to do there. Okay, then what's the next part you do? Okay, time out. Forgot to say this. Before you do your long division, the book didn't say it and I forgot to say it. Before you do your long division, always make sure that you account for every term and they're in descending orders of power. If this was a 2x plus 6x cubed plus 30 minus 2x squared, don't try to do long division with it in that order. Always get it in descending orders of the power and make sure you're not skipping a power. Look at the exponents. 3, 2, 1, 0, blast off. You're fine. If this had been a 4, 4, 2, 1, 0, oops, missing a 3, then you have to put a 0x cubed in here. You have to account for every power. They didn't tell you that, but it really is a good idea to do. In fact, almost essential. In fact, even on your divisor, you should, you've got to have a descending order of power, 1, 0, that's obvious, but you also need to account for every term. If this has been a 3x squared plus 5, put in a 0x in there, because you need to have that space count open so everything lines up here. So, time out over, let's get back to the play, okay? Now, what did you do after you divide? Say again? Not yet, okay? You just do that first term. And after you divide, you multiply. So 2x squared times 3x will give you what? 6x cubed. It better, that you divided it, it better be correct, okay? But now you do the plus 5. 2x squared times 5 would be, a little louder, plus 10x squared. Now do you see the reason you have to have the order of the powers in there? Otherwise you'd be lining up under the wrong things, okay? And why you have to account for every term. Now, before we subtracted, when it was numbers, you're used to subtracting numbers. Now you have sign numbers. And if you know how to subtract them, fine, do it. But I want to remind you how you subtract sign numbers. Change signs and add, right? That was a rule for subtracting sign numbers, okay? So what I do, because I tend to make fewer mistakes when I add than I do when I subtract, I'm going to change signs, make this a minus, and make the other one a plus, okay? Now I'm going to add, okay? And you'll notice these completely disappear. They would have if you subtracted 2, right? You want them to disappear. What does this give you when you add? Second, negative 12x squared. Perfect. Guess what you do next? Bring down the next term, minus 2x. Okay? Guess what you're going to do next? Divide, right? 3x into negative 12x. Woo. It's what? Negative 4x. Very good. Now what do you do next? Multiply. Negative 4x times 3x is negative 12x squared. Perfect. And negative 4x times 5? Negative what? 20x. Is that what I heard? Say yes. Okay. All right. Yeah. Okay. Now what do you do next? Change signs and add. That's a good way to look at it. Change signs and add. You could subtract, but, I think it's easier to change signs and add. It's doing the same thing. These add to 0, right? That's why we did it, okay? What do the others give you? Plus 18x, okay? And then what do we do next? Bring down the plus 30, and then you do what? Divide, and what do you get? Second? Plus 6. Keep the signs in there, okay? And then you do what? Multiply, and what does that give you? 6 times 3x is 18x, and 6 times 5 is plus 30. Ding, ding, ding. You came out exactly. Okay, now what does this mean? Well, this into that will give you this as a quotient, okay? With no remainder. What does that imply? This and that are factors of this. Wow. Okay? Now, another thing you might notice, if you can factor that further, which we aren't doing yet, then you might even be able to go a little bit further. Now, here's something I wish I had paid attention to at the beginning of this problem. I wish I had just looked at that and said, hey, every one of those terms is divisible by 2. Let's factor out a 2. And then when we get our final answer, we multiply back by 2. I just noticed everything is a factor of 2. But don't do that unless you feel very confident in what you're doing. I've done it enough, and I'm lazy enough, that's why I wanted to do that, but you don't have to. Okay, that's how we did it. Let's see how they did it. Any questions before I erase this? Okay, I'll wait. Got it? Okay. All right. They started by dividing the divisor into the first 2 terms. And actually, it's just the first term into first term. 3x into 6x cubed goes 2x squared times. But they don't do anything. Do something. There we go. Now, notice what they do. They move it down there. It's fine. It doesn't matter where you put it. I like to put it on top of it, even though the powers don't line up, because then when I multiply through, I remember to put it under here. But it doesn't matter where you space it. If you want to do the way the book does, put it over there, okay? And then, next step, multiply. After you divide, you multiply. 2x squared times 3x is 6x cubed. 2x squared times 5 is plus 10x squared. Okay? Now, just like before, the next step is to subtract. When I subtract sign numbers, I like to change signs and add. And they didn't, okay? So you have to think of that. If you're subtracting this polynomial here, you're changing each of those signs and then adding, okay? So that gives you minus 12x squared, okay? Frankly, to not change signs and add leads me to make errors sometimes. Change signs and add, I almost always get it right then. What's the next thing you do after you subtract? Bring down the minus 2x. There it is. And now what? Divide again. And only the first terms. 3x into negative 12x squared is negative 4x. Exactly. So write your negative 4x and y. They don't do anything. Okay? All right. It is divided by, yeah, they're writing it out down here, then they'll write it up there. I guess they will. Goodness, there we go. It's 2 clicks to get it to do anything. Minus 4x. Okay? Then what's after that? Multiply. Negative 4x times 3x is negative 12x squared. They do that in one step. And negative 4x times plus 5 is negative 20x. And then what do you do next? Subtract or change signs and add. And again, nothing happens. There we go. So, nothing happens. Change signs and add. Okay? Now, again, to me it makes more sense to change that to a plus, that to plus. You see that goes to 0, and then this obviously is 18x. Okay? Looking at that and subtracting, I get all turned around. And I sometimes we'll make an error with it. Change signs and add, to me, it's much easier. But you do it however you do it. Like. What's the next step? Bring down the plus 30. There it is. Okay, and next? Divide just the first terms. 3x into 18x is? Plus 6. Just the plus 6. Well, I have to wait. Oh, they brought down to 30. And then do nothing. Then they put it in green. That's good. And then they do the plus 6. Okay? Takes a while, but they got it done. And then what do you do? Multiply. 6 times 3x is 18x, and 6 times 5 is 30. They do that all at once. Everything else takes 3 steps, okay? And then you subtract, and you get 0 remainder, okay? Change signs and add, 0 remainder, okay? And what does that? Oh, there's your 0 remainder. So that means that 3x plus 5 times 2x minus 4, 2x squared minus 4x plus 6 is going to equal your dividend. Equals to 6x cubed minus 2x squared minus 2x plus 30. Now, they just wrote it this way. What you really should do is be checking it. So let's see if we did it. 3x times 2x squared is 6x cubed. Got it. And then 3x times minus 4x is minus 12x squared. But 5 times 2x squared would be plus 10x squared, so that's a minus 2x squared. Yeah, we got it. 3x times 6 is plus 18x, but 5 times 4x is minus 20x, plus 18 minus 20 is minus 2x. Yeah, there it is. And then finally the last term is plus 30. Okay. So it did work, and I did it arm waving. You probably would take more care and write them out term by term. Okay. Any questions on that? All right. So here's the B part of example 1. I didn't know we had an A part. Was that example 1? Yeah, that was example 1A. Here's example 1B. Your book doesn't have the B part, so this may be more like example 2. I don't think so. Okay? So you tell me what to put where. You set it up for me. What goes where? Negative 2y plus 7 is outside the house knocking on the door, and negative 8y cubed plus 30y squared minus 9y plus 10. Now, as I was writing, I was checking to make sure, number 1, I'm in descending orders of power, and number 2, I wasn't skipping any terms. Okay? Neither on the outside nor on the inside. Okay? Got it? Everything checked. So what do we do next? Divide. And what does that give us? Only the first terms. What does that give us? Positive 4 y squared. And then what do we do? Multiply. And what does that give us? Negative 8 y cubed. Perfect. Anything else? Not yet. You got another term there, huh? Yes. Keep multiplying. Plus 28 y squared. Perfect. Okay. Now you subtract or change signs and add. These disappear no matter what you do. What do you get there? That one's easy to subtract. What would that be? 2 what? Y squared. And then you bring down the minus 9. Y. Okay. Next. Yep. Negative. Yeah, negative 2y will go into positive 2y squared, negative y times. Perfect. And then you do what? Multiply. Minus y times minus 2y would be 2y squared. Squared. Okay. Negative y times 7 would be negative 7y. Okay. And then you do what? Change signs and add. Make that the negative. Make that the plus. These add to 0. And what does that add to? Negative 2y. And do what? Bring down a plus 10. Next. Divide. Negative 2y, and the negative 2y will be a plus 1. And then multiply. 1 times negative 2y is negative 2y, and 1 times 7 is plus 7. And what do you notice you have this time? A remainder of 3. Okay? So that's your remainder. All right. Now, how do they want us to write it? We'll see in a minute. Okay? You can put r is equal to 3. That's pretty clear. Okay? Another way you could, and I'm not saying the book is going to, you could also do this. I don't know if you remember long division. Give me a number, any old number. 6? Give me a number to divide into. Any number. Okay? I want to do more than that. Give me another digit. Okay, we'll do that. 6 will go into 1,214. 6 will go into 12. 2 times. 12. Bring down the 1. 6 won't go into 1. You have to put a 0 there. Bring down the 4. 6 will go into 14. Second. 2 times. 12. Remainder 2. You can either say 6 will go into 1,214, 202 times with the remainder 2, or you could say plus, or you don't even have to say plus, 2 over 6. Remainder over divisor, and that would be 202 1/3. Yeah, reduce it. Okay? So over here, another way you could say, remainder 3 is perfectly fine, or you can say plus, so that's why I did the plus, because I was thinking of this side, 3 over negative 2y plus 7. You could write it as a fractional polynomial. You don't have to, but I'm just saying you could. Okay? And then when you multiply it, you're just adding 3.
What do you want on the test?
What's that?
What do you want on the test?
I want a right answer. And if both of those are right answers, I'll recognize. You know, I grade my own test. It's not going through a Scantron and it's grading for me.
I just didn't know if you preferred one or the other.
If you write a right answer down, I'll give you credit for it. Okay? In fact, I was grading a physics paper before lunch today, and this woman missed this one answer, but she had enclosed her work, so I usually check the work for the ones they missed to see where they made the error. And guess what? She had it right on the scratch work. She just wrote it down wrong on the test. I went back and gave her the points for that because she did it right. She just copied it wrong when she wrote it on the front page. So I want to see right answers, okay? However you get right answers, get right answers. Okay. And I believe the book, well, let's see. We'll see. All right, let's see how they do it. Can I erase this? I've done a lot of yakking about it. So let's erase all that ink and see what they do. They put the negative 2y plus 7 outside the house and put the negative 8y cubed plus 30y squared minus 9y plus 10 inside the house, checking as they did that both the divisor and the dividend were in descending orders of the power and not missing any terms. If they had missed any terms, put a 0, whatever that term is in there. Okay? Now we start by dividing. Negative 2y will go into negative 8y cubed, okay, we're going to do that. Yeah, I got it. Okay. A 4y squared time, positive 4y squared time. And then they went on and multiplied right at the same time, negative 8y cubed plus 28y squared. When they go to subtract that, they get a 2y squared. Bring down the minus 9. Oh, did you see it fall like that? I didn't see that before. That was really neat, wasn't it? Okay. And then you do negative 2y into positive 2y squared. You get a minus y. Oh, you color it green first, and then you do it. Minus y. Then they multiply, all in one step. Negative y times negative 2y would be positive 2y squared, and negative y times a positive 7 is negative 7y. Then they draw a line. Yes, look at them do it. And subtract. I like to change signs and add. You get negative 2y whichever way you do. And then bring down, here it comes, the plus 10. Okay? Then negative 2y will go to negative 2y a plus 1 times. Or you do that, and you do a plus 1. Why they got it stuck way over there, I don't know. They weren't keeping them lined up too well, were they? Okay? And then you multiply, and you get plus 1 times negative 2y plus 7 is negative 2y plus 7. And then you change signs and add, or just subtract, and you get remainder 3. That's a perfectly fine answer, but they write it, like I said, with the remainder over the y. Okay? Plus. Now, if this had been a minus 3, you could put minus 3 over that. Or you could have plus here, put minus 3 there. It doesn't matter. But that is the way they want to see the answers, I guess. So if you're doing your homework exercise, do them that way, so your answers will look like the one in the back. Make sense? All right. Need it left a little longer? Okay, good deal. Okay. Now, the 10 o'clock scholar. Why do you come so soon? No, Greg, you're always here. Glad you made it. Okay. Now, here's how they wrote that answer. Dividend divided by divisor is equal to the quotient plus the remainder over the dividend. Divisor, sorry. Now, how do you check it? Multiply this by that, and you get this. Well, you've got to do each term. But when you get to that last term, this times this divides that out, and then you're just adding 3 to it. Whatever this times this is, when you do all the cross terms and everything, you get a polynomial that looks something like that, and then you just add 3 to it. Okay? Like we said before, add the remainder. And how this accommodates that is when you multiply by minus 2y plus 7 times 3 over 2y plus, minus 2y plus 7, those go away and you're just adding 3. And sure enough, that gives you your answer. Okay? Oh, now they say check it. I was already doing that. Okay? Oh, they wrote it out in gory detail. Okay. They did minus 2y plus 7 times 4y squared, minus 2y times 7, plus a minus 2y times 7 times a minus y, plus a minus 2y times 7 times a plus 1, and plus a minus 2y times 7 times 3 over minus 2y times 7. Okay? This will give you minus 8y cubed plus 28y squared. This will give you a plus 2y squared minus 7y. Well, the plus 2y squared and the plus 28y squared will give you 30y squared. There you have. First term gave you your minus 8y cubed to do. Okay? Now remember, so you've taken both of these terms. Now remember you have a minus 7y here. Down here you have a minus 2y. And that's going to give you minus 9y. You also have a plus 7 down here. And down here you have a Yeah, just a plus 3. They go away. Plus 7 here, plus 3, gives you plus 3. So sure enough, that does do it. It's a little, you have to remember your cross terms and include those in it, but that does give you the right answer. Okay, now let's show you how they did that, and how they did that, and how they did this, and how they did that. And then the first one gives you minus 8y cubed plus 28y squared. The second one gives you plus 2y minus 7y, plus 2y squared minus 7y. The next one gives you minus 2y plus 7, and the last one gives you plus 3. Because the denominator and this are exactly the same as y. Now when you combine like terms, the minus 8y cubed is the only y cubed. Combine these two and you get plus 30y squared. Combine these two, you get minus 9y. And combine these two and you get plus 3. Okay. I guess they're going to do that here. Yes, that's where it shows. Minus 8y squared plus 8y cubed plus 30y squared minus 9y. Should have included the minus in it. And plus 10. Good for them. Sort of nifty how they use the colors. Okay? Any questions on that? What's that? I can't hear you. Okay. Yeah. This is one side, all this is the other side, and then this is combining those, and that's an equal sign here. You can't see it across the line. Now, what we're doing is checking it. We divided a big old dividend, a polynomial dividend, by a polynomial divisor. We got a polynomial quotient with a not a polynomial remainder. Okay, you got a rational expression for remainder. Your remaining 3 over your divisor, okay. And then you're multiplying this out. That's what they were doing there. Okay, so it's just checking it and simplifying. Okay, if we do another one, I think you'll see it from scratch. So let's go there and do that. Example 1. This was concluded. Here's example 2. Not quite the same as the one that you have in the book, but pretty close to it. What would you put where? Tell me. A little louder?
The first one to the top.
I can't hear you. First what?
First one to the top.
Okay.
N
N minus 2, is that what you said?
the other one.
Say again?
The other one.
The other one, okay. Now, this is division, right? So you're going to need a division sign, right? Okay, I call it the house. What goes inside, what goes outside? Goes where? Inside. Perfect. N cubed. Do I just write down minus 8? Those who were here earlier should tell me this. Say again? Okay. What do you mean by that? Okay, n minus 2 goes on the outside. I'm going to go on and put it there. What goes on the inside? Okay, I thought that's what you meant. Okay. Remember, I say again? Okay, you got to put zeros for all the missing terms. See, this is going straight from 3 to 0. Hey, where's your 2 and your 1? You don't have them. So you need to fill those in. Okay? Your cost, well, no, I'm sorry. Okay. This will be plus 0n squared plus 0n. Now you can put your minus 8. You have to account for every term. I don't know if, yeah, the book does this too. You must do that. You have to account for every term. You needed to do that here too, but this was 1 and 0. You weren't missing it. But here you're missing 2. The squared and the linear. Okay? So now you begin your division. And how do you begin this? Okay, with dividing, you go left to right, not right to left. So start with the leftmost here. N goes into n cubed how many times? Nope. n, how much? N squared times. Is that what you said? Okay, that's what you should have said. Okay, right? Okay, why? Because n squared times n is, because the next thing you do is multiply. N cubed, right? And n squared times negative 2 is, help me. Wait, n squared times negative 2. Negative 2n squared. Just multiply, right? And now what do you do? Subtract. Only with sign numbers, I like to change signs and add. Same thing. So make that a minus, that a plus, now add. These add to 0. That's exactly what you want them to do, okay? And what do these two become? Second? 2n squared, right? And then you do what? Bring down nothing. 0n. That's nothing, right? But that's your placeholders. Okay, then what do you do? Divide again. N will go into 2n squared. How many times? Plus 2n times. Perfect. And then you do what? Multiply. 2n times n is 2n squared. Perfect. That's what you wanted it to be. And the next part? Yep. 2n times negative 2 is negative 4n. Perfect. And now you do what? Subtract or change signs and add. Does the same thing. That goes to 0. That's exactly what you want it to do. What does this give you? 4n. And then you do what? Bring down the minus 8. And now divide. N will go into 4n. How many times? Plus 4 times. And then you do what? Multiply. 4 times n is 4n. And 4 times minus 2 is negative 8. Look at that. It went in exactly, didn't it? Okay? That was an exact. Which means that that is a factor of this. These and those are multiplied to get that. And you can multiply that out to check it and see if that's true. I think you'll find it is true. Okay? Now, you had a remainder 0. All right, to erase?
Yeah.
Okay? Everybody? Okay? So they set it up, do the divisor outside the house and the dividend inside the house with each term accounted for. Since you're missing 2 terms here, you have to put those 2 terms in with 0 coefficients. You're not adding anything, you're just making a placeholder. Okay? If you didn't do the placeholder, had the minus 8 over here, when you do your multiplication, things are going to be all out of order. And you get confused, you get things in the wrong place, and you wind up with wrong answers. I want you to give me right answers. Remember, they're easier to grade. So I don't want you to give me any wrong answers. Okay? Promise? Okay. Never mind. All right, so let's go on from there. And they like to move it down there. And I don't care where you put it. The closest one on top. So n will go into n cubed. See, I like to do it right up there, but they do it over here because they're n squared. N will go into n cubed, n squared times. That's your division part. Then you multiply. N squared times n is n cubed, and n squared times minus 2 is minus 2n squared. Draw a line and subtract. And drop it down like that. Okay? So you subtract here or change signs and add. Either way gives you the same thing. Bring down your next term. Now you divide again. N will go into 2n squared. How many times? N will go to 2n squared. How many times? 2 plus 2n. Now there are going to be a couple clicks before they do it. Oh no, they do it. They do it right then. And they do the multiplication real fast. You do 2n times n is 2n squared, and 2n times minus 2 is minus 4n. are they going to do next? Subtract. Draw a line and subtract, or change signs and add. Okay, they make it look like a subtraction, and the 8 falls down out of the sky. Okay? And then you do. Oh, I meant to tell you this too. Remember, like I said before, with long division of numbers, if that remainder is ever greater than the divisor, divide again. Here, when you do your subtraction like that, if the power, if the degree of this is greater than or equal to this, keep dividing. You have to get it down so your last remainder is a lower degree than this one. So this is degree 1, that's degree 1, keep dividing. So n will go into 4n how many times?
4.
Plus 4 times. There they wrote it, and they multiplied real quickly, and this subtracted all at once. Okay, 4 times n is 4n, 4 times negative 2 is negative 8, and you look at that and say, hey, look at that. It goes exactly the same times, remainder of 0. That means these two things multiply to be that. And you can multiply them out and see. Okay? Now, weren't we... I'm teaching several math classes. Let me go back. Oh, a few of you came in since I passed out the quiz. Let me be sure I give you the quiz before... Well, you were here last time. Let's see. Okay. I was thinking we had done it. We really haven't. Okay. So there's example 2. Any questions? Now multiply to check. N minus 2 times n squared plus 2n plus 4. Let's do it arm waving. N times n squared is n cubed. That works. Now let's do the next term. N times 2n is plus 2n squared, right? N times 2n is plus 2n squared. But minus 2 times n squared is minus 2n squared. So the n squared terms add to 0. Okay, let's do the linear terms. N times plus 4 is plus 4n, but negative 2 times positive 2n is minus 4n. Plus 4n, minus 4n, they add to 0. That's why there's no n terms there. And then finally you have minus 2 times 4 is minus 8. So sure enough, that does work. I did it arm waving. I'd say write it out. You know, we just didn't have room to do it here. Okay. Any questions? Okay. Let's do example 3. You tell me what to put where. Second? Okay, did I hear h squared plus 1? Okay. My suggestion is, outside the house, but what are we doing? We're missing a term there, aren't we? H squared plus 0h plus 1. Even outside the house, I like to do that, and I think you'll see in a minute why. So sure enough, that's outside the house. What goes inside the house? H fourth plus 4h cubed plus 4h squared minus h minus 1. And as I was writing that, I was checking mentally and physically to make sure that we account for every term and they're in order. 4, 3, 2, 1, 0, 5. Okay? We've got them all accounted for and they're in the right order. That must be the case. See, I wanted this to be a 2, 1, 0, not a 2, 0. Okay? So I wanted an extra term in there. The book may not do it. Yes, they do. Good for them. Okay? Where do we begin? Left. The left term here into the left term there. How many times will h squared go into h fourth? Second? H squared times. Now, I like to write it here. I bet you the book is going to write it over here. So I'll do that too. H squared. And then we do what? Multiply. H squared times h squared is h to the fourth. Good for them. Next. h squared times 0h is plus 0h cubed. You see why I like that term in there? Otherwise, you might get it out of order. That makes you put it in the right place. And then the last one is h squared times 1 is plus h squared. Now you do what? Here we can subtract. That subtracts to 0. What does that subtract to? 4h cubed plus, say again? How many? You're subtracting, aren't you? 3. H squared, and you, I can't get mine to drop, but okay, minus h. Okay, good deal. And now what? Divide. H squared into 4h cubed will go how many times? Do the numbers first. 1 will go into 4 how many times?
2h squared.
Second?
2h squared.
Okay, where'd you get a 2? H squared will go into 4h cubed. 1 will go into 4 how many times? 4. So plus 4. And h squared will go into h cubed how many times? H times. Very good. Now you do what? Multiply. 4h times h squared would be 4h cubed. Just what we want it to be. 4h times 0h is 4 times 0 is 0h squared, right? It's just a placeholder, okay? And 4h times 1 is 4h times 1 is plus 4h, okay? And then we do what? Subtract. Now this one I think I do like to change signs and add. So that would be a minus, and a minus, okay? Changing all the signs, now we're going to add. These add to 0, just like we thought. What do these add to? 3h squared, and these add to? These add to negative. Second? Okay, you're adding a negative 1 and a negative 4. That's a negative 5h. And then you do what? Bring down the minus 1. Okay? And then we do what? Divide again. H squared will go into 3h squared how many times? Plus 3 times. And then we do what? Multiply. 3 times h squared is 3h squared. I could do that one. 3 times the 0h would be plus 0h. Okay? And 3 times 1 is plus 3. And now we do what? Change signs and add. So that will be a minus, minus, minus. And add. And what will that give us? That goes to 0. This goes to negative 5h minus 4. There's your remainder. How they want us to write this is, now there's two ways to write this one. Plus negative 5h minus 4 over h squared plus 1. Now notice again, time out. Yeah, you can have your variable in the remainder only if it's a lower degree than this. And this is a degree 2, there's a degree 1. Okay? So, that's how one way to write it. If you don't like all those minus signs, you could have changed this to a minus and made those both pluses. I like that a little better, but it's just a preference. You could have written that as minus 5h plus 4 over h squared plus 1. That would have been the same thing. Okay? And unfortunately, we seem to be running out of time. Is that right? Oh my, what happened to the day? Okay, let me get this erased and we'll see how they did it in the text. Okay, they inserted the 0H, then they started their division, their multiplication, their subtraction, the bringing down, the division, the multiplication, the subtraction, and bringing down, the division, the multiplication, the subtraction, and then you have your remainder lower degree than your divisor, so you write that as a plus. They put the plus minus 5h minus 4 over h squared plus 1. Notice there you don't have to put the 0h in there. That was just a placeholder for your student. Okay? It says multiply to check. I bet you they're going to leave that to the student. All right. Now, I noticed that on the last test that those people who came in late, if you didn't get it before you leave, they didn't have any of this division by polynomials. They only had division by monomials, right? Those of you who have your test out. Isn't that all they had on there? So I have a feeling I put that in extra. Don't think it's hurt us a bit to do it, do you? In later courses, when you go on the Math 100, you're going to have to do it. So hopefully I've introduced it to you. Do you want to continue? We've got examples 4 and 5, and that's all. Let me go and give you homework exercises. Do any of the 5 through 16, and do any of 17 through, I'd say 28. Okay?
What page?
That's on pages 900 and 901. So my question to you is, do you want to finish the last 2 examples here, example 4 and 5, or do you want to move on to chapter 14? Because we're not going to do 13.8. It's scientific notation. You should know that already, but it's not required in the course. What's your feeling? We are running out of term, so what does that mean? 4 and 5, or move on to chapter 14? What does it mean? 14 or 4 and 5? Doesn't matter? What you all think? I don't think you're going to have division by polynomials on the test. It doesn't look like you are. So you want to go on to chapter 14? Okay. So we'll start there on Monday. Is that okay? All right, good deal. Now, if I find out otherwise, we'll go back and review that. Did you not get a test before? Okay. Anyone else who needs a test? Today you didn't have to leave a little early, huh?
I was in the middle of trying to convert a part to another part of the software, so.
Okay. All right. Now, on this, they said Unit 3, which I thought was Chapter 13, but they did 13 and 14. So all you have to do for the test is 1 through 11, because that's what we did here for one division. See, they only divide by monomials. The rest of these are factoring, okay?
So they solved 13 and 14?
What's that?
They solved 13 and 14?
What?
They solved it?
Solved what?
The problem.
No. All I'm saying is what we've done in Chapter 13 is 1 through 11. 12 through 20 is Chapter 14. Chapter 13, what we were just doing, that's 1 through 11. Chapter 14 is factoring. So you don't have to do these last, 9. Okay? If you want to try them, you can. If you get them right, you get bonus points. If you miss them, it doesn't hurt you. It doesn't count off. If you leave them blank, it doesn't hurt you or count off. But you're going to be graded on the first 11, and then if you get any of the others right, you get bonus points. Now, the bonus points are only good through next Wednesday. If you turn it in by next Wednesday, you get bonus points. Turn them in after next Wednesday, I'm just going to grade the first 11 with no bonus.
When is the test?
What's that?
When is the test?
We'll have it probably Wednesday, I'm guessing. Okay, if not the next Monday. Okay, well, we may wait till the next Monday. But see, I want everybody to turn that in before we get to do the test. But if everybody who's here has turned in the test and is ready for it, we'll do it on Wednesday.
What about all that previous math that we did before?
What's that?
What about all that previous math we did before? Is that going to be on the test?
That'll be on the final exam. Yeah.
So
It's a departmental final. I don't make up the final. By the way, you'll notice this, all those first 11 are multiple choice. Don't expect to see multiple choice on the test. I do short answer, always. Yeah, you have to show me your work time.
Right. So the final exam is going to be what, 300 questions or something?
At least. No, I'm just kidding.
No,
No,
I was like-
it's probably only going to be about the same length as that, 20, possibly as many as 30 or 40, but I doubt it. Because those just take too long. But you see, I don't make it out, so I don't know. I'm guessing it's going to be about the same as that, or a little bit longer. And if it's not, I'm going to give you as much time as you need to do it.
Thanks.
Okay.